We're going to talk about the Gestalt approach to object recognition. So the Gestalts were a group of German psychologists in the early parts of the 1900s. And up to this point, a common view of perception was that uh, we recognize things uh, by constructing it from little bits of information. So little bits then would lead to us seeing the whole. Okay? Uh, this is really a view that comes out of structuralism, which had been proposed by the very first psychologist, uh, Wundt. So one day, um, a man named Wertheimer, Dr. Wertheimer, was riding on a uh, trolley or a train, I don't remember which. And he had with him a toy that he was going to give to one of his nephews, I believe. And it was a toy stroboscope. Okay? Uh, I'll post that video for you to watch. But stroboscopes were basically uh, um, common before there were movies, right? And stroboscopes create the appearance of motion, even though it's not. And so you might there's various kinds of stroboscopes, but um, it's basically looking through a viewer, and you could spin uh, a little cylinder around, and on the cylinder would be different pictures. And even though the pictures aren't moving, they would have the appearance of movement. That's apparent motion. Okay. And again, I'll post that video so you can link to it and watch it, and you can see an example. Okay. Um, and in watching uh, the stroboscope work, Wertheimer had a moment of insight. Okay, and that insight is kind of expressed by um, this famous line from the Gestalt School of Psychology that the whole is greater than the sum of its parts. Okay? Uh, and what they're arguing here is that we don't build up perceptions from little bits, that what we're seeing is something more than all those little bits. Okay? And that we see the whole first and then we make sense of it. And what they also argued is um, um, that this is an essentially a native process. It's something that our brains do, our perceptual systems do automatically. Okay, and so they proposed a number of laws. They're not really laws; they're just heuristics. Heuristics are rules of thumbs, but basically what they are ways or kind of shortcuts that our perceptual systems make in order to identify objects. So here is Wertheimer's argument of these factors and principles point in a single direction. Perceptual organization starts from above to below. Okay, so the whole to the parts rather than from the parts to the whole. The way in which parts are seen, in which grouping occurs, is not an arbitrary piecemeal summation of elements, but it's a process in which characteristics of the whole play a major determining role. Okay? So it's the characteristics of the whole that determine how we see things, not the little bits that determine how we see things. So let's look at that a little bit. Okay? So they were the first ones to talk about figure ground, okay? And that picture of the urn or the faces comes from the Gestalt school. Okay? And they focused on how we group objects. Okay? Uh, and they proposed what's called the law of pragnance. It's also called the law of good configuration, law of simplicity, the law of good figure. It's hard to just translate the German exactly. But, but what this law is basically saying that we have a tendency to perceive the simplest figure possible. All right, we see things as simple and complete rather than as complex and incomplete. Okay. And this is why we make out images even when they're not there, like seeing Jesus on a piece of burnt toast. Now, I think that's an actual image of Jesus on a piece of toast, but you've probably looked at pieces of toast and thought, it looks like a face or something. Certainly, when you look up at clouds, you will make out um, faces or elephants or whatever. All right, we tend to look at things and create patterns in that that are familiar and simple. Okay. Now here, the good, good simply means simple rather than complex. All right. So why? Why would we have to use some kind of general rules or shortcuts in order to understand things? Okay. Well, what you have to understand is that cognition itself is limited. We have limited resources for attending to things, for perceiving things, and if you remember from when we talked about Hermann Helmholtz, um, um, that uh, we didn't talk about Hermann Helmholtz in here, so just ignore what I just said. Um, one of the things that Hermann Helmholtz discovered was um, that nerve conduction wasn't instantaneous. Up to early 1800s, that's what people believed. But Helmholtz tested the speed of nerve conduction first with frog legs and then with human legs, and found that there's that it's not instantaneous, that it takes time. Okay? It's still fast, but it takes time. So really, by the time we become aware of things, they've already happened. Okay? We're aware of things that have just happened in the past. It's only a split second ago, but it's still in the past. Okay? So we have to make things out quick in order to keep up with what's happening now. Right? So it works better if we're grouping things together into some kind of heuristic and responding to it rather than trying to make sense by building things up from different parts. All right, so let's look at some of law examples of perceptual grouping and the laws that go with them. Okay, this is called the law of good figure. Okay, uh, even though they're not in colors, you may recognize this as the Olympic rings. Okay, now we see this really as a grouping of rings. Okay, um, but in reality, we could, or as far as possibilities go, we could see this as more complex, right? We could see this, you could see this as one object, this as another object, right? This is another object, and then it kind of would look something like this. But we don't. This is complex, this is simple. Okay, so this is the law of good figure simplicity. And again, we see this as a whole, as a cube, but in reality, but we could also, all right, see a little square here in the middle. This would be one shape. Here's a triangle, and so forth. Another triangle. But we don't. We don't see separate figures. We see it as a whole. Now, this is a colon and a closed parentheses. That's a colon and closed parentheses. That's a colon, a dash, and a O. Okay. But we don't see it that way. All right. We see this as a happy face, a sad face, um, surprise face, whatever that's supposed to be. Okay, but we see a face in there, even though there's no face. Yeah, and that's um, again because of the this heuristic where we are putting things into a simple figure, a smiley face, rather than something complex, colon, close parentheses. Yeah. So if our perceptual systems work differently, we wouldn't have these emoticons. You know, they wouldn't make sense to us. Um, but yeah, as a result of this, our perceptual systems are creating patterns even when they're not there. Okay. If you remember from the previous video, the arrow that that you saw, um, even though it wasn't uh, created, that's a Gestalt image as well. Okay, but that's again why people see Jesus and piece of toast, or you know Elvis on some mold growing on a wall. Okay, you know that our systems are creating patterns whether they're there or not. Okay. And it's not just with vision. We do it with all our other sensory systems as well. Okay. A good example of that. Let me back up for a second. Um, if you've done any traveling and you've been in a foreign land and they're speaking a language other than English, for whatever reason, why doesn't the whole world speak English? But you know, most of that you're gonna have a hard time understanding it. Right? But every now and then you may think that you hear an English word. Okay? This has certainly happened to me. Um, and you're not hearing English. It's just that your perceptual system's trying to make sense of it, and there'll be some pattern of sounds that is uh, close enough to an English word that your perceptual system will create it. Okay. Uh, for a while, we had an Indonesian woman living with us, and she spoke Chinese. She spoke English very well, but she also spoke Chinese, and she was talking to her fiance in Chinese one day, and I swore I heard very distinctly an English word. I forget what the actual word was, but it was just so clear. But I knew that they actually hadn't said it, and so I asked them, "Did you just say?" And they just laughed and said, "No, we didn't say that." Okay, so again. If you ever travel, you'll hear more English than is actually being spoken. Okay? Okay, so let's look at some of the actual laws of perceptual organization. One is the law of proximity. Yeah. So you can see this grouping of dots. We have 3 rows of 3 dots, um, three rows and 3 columns of dots, uh, and the question is, how do you organize these? Okay. And the way this is set up is there's more distance here than there is here. And so you're probably grouping these vertically. Okay. If you had more distance, or if they were closer together here and here, but further apart, if the rows were further apart, then you would group it horizontally because it's the columns that are close together rather than the rows. This is the law of similarity. You group things that are similar. So you probably have a grouping here, a grouping there, and a grouping here. Okay? And you might find that you kind of go back and forth between grouping by similarity and proximity, so that sometimes you're putting the columns together and sometimes you go back here. Okay? Because this is one where you have this ambiguous, um, do I your perceptual system's going to go back and forth trying to decide between proximity and similarity to do that. This is the law of good continuation. Right? This line could be going that way, and this line could be going that way. But instead, you see this line as distinct and that line as distinct. This is the law of closure. Even though it's not closed, we see that. Our perceptual system will put that, will in a sense fill that in So we see this as a distinct square, even though it's really not. It's not a square because it's missing a spot. Okay. Okay. Law of proximity. Okay. You, you should be seeing this as distinct from this, as distinct from that, rather than this line distinct from that line, distinct from that line, distinct from that line. Law of similarity. All right. You're probably grouping the dark ones as one group and the light ones as another group. Okay. You probably see A to D as one line, C to B as another line. All right. But for all you know, CA is the line and DB is the line. Okay. But our perceptual system is going to see C to B as one line, A to D as the other. Law of continuation. This gives a sense of movement, like the leaf has moved through all of that. Okay, so we see this as the path that the leaf is following. Okay, it's really not. The leaf is there. Then we have this kind of swoop going through the H. But this is also an example of completion. So we see this as an H. Okay, or at least as two eyes, even though it's really, you know, we kind of have one shape here and another shape here. And you can see that there's not really a line there, but you probably see uh, see that this part as distinct from that part. Okay. You probably see that as a dog. It's really just a bunch of splotches. And you might remember this from early on in this class. Right? Your perceptual system wants to group things. It wants to complete this figure, but it's a little hard because it's not following the normal laws of things. All right. Another is the law of symmetry. We perceive things as symmetrical, formed around a central point. All right. This is really just a right or left bracket and a right bracket, but we could see that as distinct. Here we might even start seeing it as two faces. All right. All right. There's a lot going on in here, a lot of different laws. All right. We have proximity, similarity, okay, symmetry, continuation. This is called the law of familiarity. Okay, you look at this, you see a house, but it's really not. It's a triangle. It's a square with a rectangle in it. Okay, or it's a square with a hole in the middle, or a rectangular hole in the middle. Okay, we even have a space here, but you put that together because it's this. When you put a triangle over square, we tend to see it as a house, especially if you put a door on it. Right? Yeah, this is the law of common fate. Okay, we see this all as one. Okay. Now they use this. All these laws are used in graphic design. Okay. But they're also used in movies. Okay. So you can think about a movie uh, when someone is feeling happy and ecstatic and things are going with them, you'll see them moving with the crowd. Okay? When things are falling apart for that person in the movie, you'll see them moving against the crowd. Right? So they really stand out in isolation. All right. So again, as I said, you see a lot of all these principles are used in graphic design quite a bit. This is supposed to be a mermaid, but there are a lot of different laws in effect. Okay. Oh, there we go. And this is why sometimes you see things that aren't there. Okay. A friend of mine, this is not the picture. He didn't send a picture, But a friend of mine was running in the mountains in Virginia, where there are no mountain lions, at least not at the moment. But one day he swore he saw one. Right? And then when he took a closer look, he realized it was just a stump. Um, and this would be more like an African lion with a mane rather than a mountain lion. But I've been fooled many times by old trees and stumps. Just the other day, I was even though it was 30 degrees, mid-February, time when you don't really see any bears on the trail. I swore I saw a bear. I stopped running, stopped moving. I yelled, whoa, bear, go away." And I kept waiting for that bear to move. And I swear, whenever I tried to get a better look at it, um, his head moved. And after a while, I just thought, okay, this can't be real. And as I got a little closer, I realized it was just a tree. It was all blackened. It had a little uh, kind of this had kind of two flaps coming up the side that gave the appearance of ears, and so I got fooled. But man, it was a very real looking bear. Okay, but again, it's because of how our perceptual systems work. They try to create something familiar, something simple rather than complex, and so sometimes we see things that aren't there. All right. Now, why? Is our perceptual system doing this? Well, it's fast. It's safe cognitive resources. It makes it easier for us to remember, and it's automatic. It just happens. Okay, and because it's automatic, it can take a while to unsee something. Like the thinking I saw a bear when it was just a tree. So a bear is not always a bear. And thank God I have never actually seen one. Though, for the most part, black bears are going to run away from you. I still don't want to run into one. Okay? Um, Here's a definition of a fractal. Okay? Um, there are a lot of patterns in nature that repeat themselves, like spirals, like these of um, tree patterns. Where you have a branch and then you have a trunk and then branches that come off it. This is from a leaf that's on a tree, right? Neurons kind of have that same sort of pattern. Okay. Um, so this is the idea behind fractals. Well, you don't need to know what a fractal actually is, but these are ink spots from a Rorschach test. Okay. They're really just random patterns. Rorschach just took some ink, spread it on a piece of paper, folded the paper over, yeah, and got these different patterns. Okay? And people will see images there, even though there's not really an image. Okay? Um, and it turns out the more that you have kind of a repeating symmetry, that's the idea behind fractals, the more likely someone is to see an image in something. Okay? But again, if we weren't automatically grouping things into some and automatically seeing figure ground and automatically seeing the simplest thing there, we wouldn't see any kind of image within a ink blot. This is Jackson Pollock, a very famous painter, and this is the way he painted. He just threw stuff on a canvas, basically. Okay? And his goal was to create things in which you didn't see a pattern. Okay. And so when he was painting, and if he started to see a pattern, then he knew he needed to kind of adjust the painting some way to get rid of those sorts of any kind of perception of a pattern or an image or anything like that. Okay. Okay, so the homework here is to find a product label. Can't do Starbucks because that was in this slideshow, but find some product label and identify the laws of perception that are used in the design of the logo for that product. Okay, and that's the end of this video.